This is the Chapter 4 review. This is problem number 5. Solve the following equation algebraically and graphically. So we're going to look at number 5. We're going to start out solving it algebraically first. Some things to notice right off the bat. We have x plus 4 squared minus 3 equals a negative x minus 1. So we have an x on both sides of the equation, and this one's trapped inside the grouping symbols. Now there's going to be a lot of people who are going to want to just automatically go ahead and take the square root of each side, but you want to think about it. Is that going to get you anywhere? You're going to take this x out of the grouping symbols, but then this one is going to be put into grouping symbols. So we're not going to be able to solve anything with an x trapped inside some grouping symbols. So probably the better way to approach this problem here is to get rid of this group here by FOILing this out or multiplying the binomials times each other and then combining all the like terms. So let's take a look at that approach here and see what we get. So we have x plus 4 squared. So when we take that and we multiply x plus 4 times the quantity of x plus 4, we should get x squared plus 8x plus 16. We still have minus 3 equals negative x minus 1. Now, there's always people who are going to be hesitant to do that, or like I said, want to take the square root of each side, but that's why you got to pay attention to what's on both sides of the equations first. Now, I can go ahead and simplify this side. I have x squared plus 8x plus 16. I'm sorry, well, plus 16 minus 3b plus 13. And that equals negative x minus 1. Since it's quadratic, I want it to equal 0. So I'm going to add the x from the right side to the left side. And in that same step, I'm also going to add 1 to each side. Now we're at x squared plus 9x plus 14 equals 0. We're going to look at this trinomial here. There are no common factors in it, so we're going to look to see if it factors into two binomials. So I'm going to set those up. This is an easier one because there's no coefficient in front of the x squared. So we're going to say this is going to be x, this is going to be x. We've got the signs are going to have to both be plus. And then factors of 14 to add to 9 are 7 and 2. Now we'll use the zero product property and set each of those quantities equal to 0. We'll get x equals negative 7, or x is going to equal negative 2. So that looks like a pretty good solution there. If we took them and plugged them back in, negative 7 plus 4 would be negative 3, squared would be 9, 9 minus 3 would be 6, and then when we plug in negative 7 over here, the opposite of negative 7 would be 7, minus 1 would be 6. So this one's going to check out, that one works. And when we plug in negative 2, it's also going to end up working there. Let's see. Negative 2 plus 4 is negative 2. Negative 2 squared is 4. 4 minus 3 is 1. And then when we plug in the negative 2 here, the opposite of negative 2 would be 2. Minus 1 would be 1. So they both work, which is really nice. So we solved it algebraically. Now we're going to look at solving it graphically. And remember, there's two methods for solving graphically. One, you can get it and set it equal to 0 and then graph it and find the two x-intercepts. Or we can take each side of the equation and graph it like it's its own function and then find the x-coordinates of the intersection points. And that's what we're going to do here. We're going to say y equals the quantity of x plus 4 squared minus 3. And we're going to say y equals negative x minus 1. So this one's going to be a parabola. The vertex should be at negative 4, negative 3. It's got standard growth here. The a value is 1, so we know we're going to go over 1 and up 1, over 2 and up 2 squared, over 3 from the vertex and up 3 squared, there we go. And I'm going to go ahead here and start connecting them there. Hopefully I can draw it somewhat accurate here. Now, because we're solving by graphing, it is important that you try to make it as accurate as you can. The tools I'm using make it really hard to draw, so I'm doing my best. Yikes. Just bear with me there. All right, now let's look at the second one here. This is going to be a line. We're going to have a y-intercept of -1. So we'll make this blue so you can see it a little easier. There's -1. Our slope is -1, so we're going to go up 1 and back 1. Up 1 and back 1. All right, there's going to be no chance I'm going to draw that straight, so I'm going to cheat here. Let's just kind of draw in our line this way. Oh, that did not do it. Let's try that one more time. Oh wow, look how straight I can draw. Go me. All right, so in all seriousness now, we look here, we've got an intersection point there, and we have an intersection point right there. So what we're going to have is, you'll see that this one is back at -7, 1, 2, 3, 4, 5, 6. So we're at the point -7, 6. That there, all right. So -7, 6. And we're at the point -2, 1. Now remember, we broke this into a system of equations, so it looks like there's points for our answers. But our original equation has just x's, so we have to focus on just the x coordinates. So x equals -7 and x equals -2 when we look at solving it graphically. This is problem number 5 from the Chapter 4 quiz review. Hopefully this helped you out. If you have questions, please make sure you ask your teacher. Thanks for watching.